And welcome, and today we're gonna learn from this book, The Car Care Book, written by Ron Hafner. Hafner. So thanks to Ron Hafner for this book, wonderful book. So the title piece is The Car Book, and this is the fourth edition. And Columbus High School, Columbia, Newenberg, whatever, I don't know. Okay, I tried to make them. Now, what is in the content? Let's see. First is Dalmar change learning, engage learning, whatever. What is in the content? So first is what make this the wheel go. First is the basics fundamentals, how it all fit together, the energy, force, work and power, and converting heat energy to motions, the engine as a group of system transferring torque, brake, steering, suspension, tires. So this is the basics of what car actually have. So first we will learn about the basic physics of work, power, energy, then motions, then basics torque and brake system, steering, suspension and tire. All this is very basic stuff, and definitely we should deal before we start this. And what are the tooling up? So awareness, what are the tooling up? We have awareness, a starting point, level of commitment, safety and precautions for car care, inspections and basics maintenance under the hood, inceptions and basics maintenance under the car, basics mechanical tools, supply and associate accessories, maintenance and minor repair under the hood, and maintenance and minor repairs under the car, turn up and basics electric work. So this is a complete machines that run. So first is and then thereafter we have an engine, the very basics of gasoline engine, 4-stroke cycles, then routine engine maintenance, engine problems. What are those engine problems that we face? We will definitely address them. Now then we will talk about the fuel system. Actually basically the engine run with fuel is a blood of engine. Now the gasoline, we will first talk about the fuel tank, fuel pump, fuel filter, then we will talk about air cleaner, fuel delivery systems, emission control, then OBD2 is scanning systems and all to check its performance, then safety precautions for fuel system maintenance, fuel system provision problems and diesel and differences. The electrical systems, the overview, first is we will talk about the batteries and all, then safety precautions for battery and electrical system maintenance, the battery maintenance, the steering system maintenance, charging system maintenance, and ignition system maintenance, light and accessories, and maintenance for light and accessories, electronics devices, maintenance for electronics devices, electrical system problem, future electrical systems are here also. And in the 6th chapter we will learn about the lubricating and cooling system. First is we need to cool our engine. Engine become very hot when it compress, and when it start combustion. So that is what we need to cool, and the need of cooling and lubrications, the lubrication system precautions for lubrication systems, then lubrication system maintenance and problem. What are the problem we face for cooling system and lubrication system? So definitely that is what we need to address. In the 7th chapter we will talk about the and then we will talk about the derivative functions and options, then transmissions, manual transmission, clutch, manual transmissions and automatic transmissions, then differential, front wheel drive, rear wheel drive and 4-wheel drive, then safety precautions for derivative maintenance, routine check and lubrications, then derivative preventive maintenance, then derivative problem, then shifting problem. Then after we will talk about tires and brakes, the tires, routine tire maintenance, the brake system, anti-locks brake system, traction control, parking parking brakes, safeties, precautions for brake system maintenance, routine brake system maintenance, and brake system problem. Then we have in the ninth chapter suspension and steering. So the suspension systems, routine suspension maintenance, steering system, power steering system, wheel alignment, routine suspension and steering maintenance. Then we will talk about suspension and steering problems. So this book is definitely, after reading this amount of content, we learned that they deal each and every part, and also the problem, the solutions, and how we can take care of this car. So this is very basics, and every individual should know and learn this stuff. So then we will talk about the heating, air condition, and optional equipment. So this is the 10th chapter. We will talk about the heating system, routine heating system maintenance, then heating system problem, air conditioning system, automatic temperature control system. Then we will talk about this maintenance and condition system problem, air conditioning system problem, and optional vehicle equipment. Then we have maintenance, your maintenance program. So the importance of maintenance: when you buy a new car, you need to take care of it. In the period of time, you need to maintain. You need to give him a proper lubricant, check all the accessories are functioning well. That is what we need to maintain and check maintenance. So individualizing your maintenance program, then daily maintenance, weekly maintenance, or after mileage, after 3,000 to 75,000 mileage maintenance, then 12,000 to 15,000, then 30,000 to 60, and replace spark plug and inspect ignition system. Then interior car, then exterior car. And at the 12th chapter, we will talk about the repairing. So recognizing repair needs. Should you do it yourself? So basically, don't be a doctor at everything. So you may know something, but better is go for the experts, and the expert who can solve your problem more better way. So yes, either be an expert or visit the expert. Then changing an alternator, then changing valve cover gaskets, and changing the thermostat, then searching for repair service. And where you should go for repairing, the traditional way or conventional way, where who charge more, you don't need to go there. Go where you get cheaper, but better is, if you have money, then go with the authorized one who can do it cheaper as well as do it in a correct way. So the repair IT and replace IT decision. So understand your motivations, the evaluate maintenance and repair cost, estimate market value of your present vehicle, set your budget, consider total ownership cost, understand the impact of your decisions, buying tips for parts and insurance. So while you buying, what should be you should think of, like buying insurance or buying parts or extended warranty protections, when what to do in an accident, that is also important. So buying a new car, deciding to buy a car, be a prepared shoppers, information sources, the test drive, features and options, determine the value of your car, getting the value out of your car, to buy or to lease or pay for the car, determining the vehicle cost, additional cost, adds on, low hassle options, negotiating yourself, going to the dealerships, and tactics and tricks of the trades. And then leasing. So leasing considerations, leaser versus loan. So how you should buy a car, if you want to buy it for lease or in a rent, and if you want to buy it completely, the ownership will be yours. So why and how you should go with, and what are the best option for you. So some things you need to know about a lease, and what to expect at the end of those lease, some final tips. So at the end, the 17th chapter, we will talk about the electric and hybrid cars. Nowadays, the modern car are coming, like electrical cars, and there are also a hybrid car is available. Like you can run them in electrical as well as in the fuel. So then hybrid engine we need, then hybrid operations, maintenance and accident safety. And this is what the content. So after reading this content, we get a pretty much informations about what are the basics things we need to be consider while we are going to buy, like while you're going to buy a leasing a car or buy a new car, or what are the tips and tricks that you need to have. Then if you buying car, now maintenance, right? First you need to know the basics concepts of the car, like if you are and don't be a doctor of car, right? So if you start treating them and don't be an expert, if you be in your expert, be the expert in your field, right? Don't jump in other field. So that is what you need to be very careful while you are doing. Now where and how to repair, what are the basics things that you need to know. So these are the very important concepts and the very important things that we need to know. So we will start very soon. So first chapter we have in the content we read, we say that what it makes the wheel goes, the basics of car, how car run and how it works, basically the physics behind the car. So what we have is, the objective is, after reading this chapter we should be able to list the major system and components of the automobiles and describe how energy, work, force and power are related to one another, and explain the conversions of energy into motion, so how it all fits together. The automobile has been around for more than 100 years. It has evolved from grass buggying built in the late 1800th century by Daimler and Benz in Germany and by Henry Ford and Ransom Olds and other in the United States, to our present days. Automobile composed for more than 15,000 individual parts. So the early era cars were at their time complex machines that could only be enjoyed by the wealthy and repaired by dedicated and trained personnel known as mechanics. The traditional mechanics no longer exist today, like the doctor of body and now doctor of car, right? So that time people don't have knowledge. Nowadays people almost aware about that. So the technicians often specialize in the specific area of the automobile, such as driver ability and diagnostics and electrical and electronic system and driver train transmissions and suspension and steering, brakes and body systems. So this specialization has been made necessary by the many complex electronics and compound systems found in today's car. So the relatively recent advance of electronic systems on the modern car has transformed it into a self-diagnostics and, on an extent, self-adjusting machines. So when you look under the hood of today's automobile, the maze of tube, wire, hose, belt and other parts may seem intimidating. So don't let this first view alarm you. So you can become more comfortable with that you are looking at by becoming familiar with your vehicle. So let's start by dividing the car into its major sections and their subsystems. So first is, let me show you in figure 1, and this is a basics of car. Let me show you. Okay, so the first thing is the show the major sections here. First thing is the chassis. Where is this chassis? Okay, this is chassis. Okay, this is the chassis. The underlying structure or comprised of a passenger compartment, engine compartment and doors or fenders, on which all other parts are mounted, including the steering, suspensions and brake system. So this is the box, outer shell. A chassis or unibody and engine placement and drivetrain for both rear wheel drive and front wheel drive, RWD and FWD. And then we have this very basics engine. So nowadays we have different types of different diversified of engine and model, but almost on an average this is the basics fundamentals, this is the basics component. So the engine is an internal combustion device that take in air and fuel, converts the expensive force of the burning air and fuel into rotary motions and used to supply power to the automobile. So what engine does? Engine consume the oil, fuel and air, and it actually burn and create a force and start the rotating motion. Now then we have drive a train. So this box is actually very uniquely designed, a gearbox you can say, and drive train. So this is actually what control the wheel. So this consists of a transmission and other parts that transfer the power produced by the engine to propel the car. So this is who transfer the force into the wheel. Then we have the engine and drive train together comprise the powertrain. So this is comprised as a powertrain. Sometimes this term drivetrain and powertrain are used for one another but they refer to different things. In these books, you will learn about many of the parts and systems that make up chassis, engine, powertrain, and body components. So you can use this basics understanding to perform preventive maintenance, diagnostics, common problems, and do some simple repair. Right? After reading this, after completing this, you can do this a basics repairing. Now let's dig into this physics behind this car, how this car works. So then we talk about energy, how it produced, and then force, how it works, and then power, where this comes from. So although you may not realize it, you already understand the basics physical process that make the wheel go. For example, consider that what happens if your car stall in traffic. If you are strong enough by yourself to get enough people to help you, it's said that the average human can produce amount of 1/3 of 1 horsepower. So average human can produce 1/3 of 1 horsepower. So you can push the car off to the side of the road. The movement of the car results from the use of energy. So you need energy to work, and to work you have to push the force, you have to apply force. So applying force, so energy can take 6 forms, like chemical energy. So there are many kind of energy, like chemical energy, mechanical energy, heat energy, light energy, electrical energy. So we have around 6 energies, right? So light energy for coming from sun ray, heat energy from burning anything, whether it's a sun or anything fuel burning, it's produce heat, or like coal burning, heat producing. Then mechanical energy is like machines that produce mechanical energy, and then chemical energy is that chemical produce. And radiation energy, radiation also have an energy. So a tightly wound one spring in an alarm clock store mechanical energy. Human beings and animals store energy chemically in their muscles. So we have store that energy, chemical energy, in our muscles, and then we produce the mechanical energy, like when we move our hands and body. So it's first we eat foods that produce chemical energy, then it's stored in our body. Then we have physical energy, or mechanical energy, that to move our body. When we move, it's we using the convert it into mechanical. Now, so energy we see. Okay, so let's learn some basics of physics. So energy can take 6 forms, as I said, and human beings and animals store energy in chemically. A battery store chemical energy and convert it into electrical energy on demand. When the flame on a gas stove is light, heat energy is present for cooking. When a light is turned on, electric current pass through a filament, and that heats up and give off light energy. And examples of radiation's energy would be X-ray. So we convert one energy to another energy, like light, heat, mechanical, chemical, electrical, and radiation. So we can convert them in one to another form. Now what happened in the car? Before that, we need to understand the force. So when you push the car, you use energy to apply force, right? When we have energy, we apply force to move something one position to another position. So force applied to an object cause motion. So if you give them force, it start motion. Motion can be a linear or non-linear, and okay, discussable. So if you have to push the car very far, you will have done a good bit of work. So the sum of this distance, if you move a car a some amount of distance, so you apply force and then distance, if you multiply together, and you will get the work. So basically work is the results of applying force to an object and causing it to move. The formula to calculate the work W, if you say work W involving multiply the distance, trouble D, force F. So that's what is the formula we form. Now power, what is power? Now power is the amount of time it takes to do this work. So that is power. So in a simple way, the power is the rate at which work is done. So rate at which work is done. For example, how fast you are able to do the work of pushing a car, that is power. So the more the power you have, the more you can do it more fast. Is calculated by using the value you get from work, right? We have done that work and then divided by time. So in a unit time, how much work we have done, so that is our power. And often we have horsepower, many times we count them as a horsepower in vehicles. So the value we get from power is not immediately meaningful to us, so we convert power into horsepower. Now horsepower is 33,000 foot-pound per minutes. So we divided power by 33,000 to get horsepower. Now this is all mathematical term, you don't need to learn. It is basics of science class, intermediate class science. Now move on to actually what we want to learn. So now what HP or horsepower rating for an engine has more meaning when we talk about work and power. So if you have more energy, you can apply more force. So if you have more energy, more force and more work done, and that is why you need more power. So the fast the work is done, the more the power you are using. So these concepts are summarized here. Let me show you. So you apply the force on the back side of the car, and car travel a distance, wheel start rotating and it's travel some distance, that is our D. So work is the force applied to a vehicle that cause it to move a given distance, and the rate at which the distance can be covered is an indication of power. So for example, you travel that distance in a T time, right? So the time take is T. Now the less time, the more power. If you want to go faster, then you have to increase the power, right? So that is why you press in the class more, so it start more fast. So a car engine use the energy present in its fuel to apply force and move the vehicle. The engine produces torque, a twisting force that turns the driving wheel. This torque acts on the crankshaft. We will talk about that. So that will convert the reciprocating or up and down motions of the pistons into rotatory motions for use in the car. So as the engine apply torque and moves the car, and work is performed. So that is the basics fundamentals. A car engine use the energy. Okay. A car engine use the energy present in its fuel to apply force to move the vehicle, and the engine produce torque. So now you understand the torque, right? Torque is very important. Producing torque and twisting force to turn. Actually, torque is actually the rotating force, you can say, which will help to rotate. When you push, you push force, but in the wheel it start rotating, so it's a torque produced here. Now converting the heat energy to motion. So a car engine is a machine or mechanical device that change chemical energy. Chemical energy, we have fuels, and it convert this energy into heat energy. So it produce heat, it become very hot, and the results heating energy into mechanical energies. So there is an engine who can convert this one to another. The burning or combustion, we use combustion here, of chemical energy rich gasoline. So energy is stored in this chemical, that is gasoline or fuel, whatever this petrol, oil, whatever fuel you will use. So or either it is diesel. So fuel produce the heat energy. This heat energy is converted or changed into mechanical energy, and that's turns the wheel and moves the car. Two types of engine commonly have been used to convert heat energy to motion. One type burn the fuel inside the engine, and this type is referred to as internal combustion. So there are two types of internal combustions and other is external combustion. In this internal combustions, what happen that fuel burn inside of the engine, and the other hand the fuel is burned outside the engine, and those engines are called external. So external combustion means outside, external outside, external is outside. So external combustion engines, let's talk about that. So an old-fashioned steam locomotives is an example of an external combustion engine. The burning of fuel in a firebox turn water into steam. The steam is rotated to a power cylinder mounted on the side of the locomotives. The steam push against a tight fitting plugs called a piston inside the cylinder. The hot steams create, okay, first is very important, it is a steam engine, fine. So this external combustion engine use pressure from steam created by boiling water, boiling water. So the steam pressure push the piston in the engine. So what happened is, let me show you in this diagram. So we burn this external combustion engine, we burn the water and it's become hot, and this steam is being transferred to the rotatory part of this engine and it start rotating. And this is a piston, and that's what it happened. It's a very, when you see the animation you will definitely understand. Actually we refer the animation, watch animations to understand that how actually combustion happened here. So and this is external, right? So the actual steam engine, the cylinder is usually located just ahead of the drive wheel of the train. Thus external combustion engine are generally too big, too noisy and too messy to be used for personal transportations. But people try anyway steam driven automobile of the early 90s. So that time we have steam engines, right? And a liquid or fuel engine, but it's a external combustion engine. So but people try away steam divided automobiles to the early 90s, and nowadays steam engines of the day we are too cumbersome and took too long to produce steam to be practical for everyday use in automobile. Now let's talk about internal combustion engine. The personal vehicle that generate its own horsepower become feasible with the introductions of the internal combustion engine, which burn an air-fuel mixture inside a cylinder within the engine. Above the piston, that burning procedure heat that rapidly expands the resulting exhaust gases and in turn produce a pressure. The pressure force the pistons down the cylinder. The positions is concreted by a rod to a crankshaft. If you have ridden riding a bicycles, you are familiar with the actions of crankshaft. So your legs move up and down to pump the pedals mount on a bicycle crank, so or crankshaft. So the crank turn in a rotating motions to drive a chain that power the bicycle. So the crankshaft and paddles rotate within bearings that allow them to turn freely. So in an automobile engine, so several pistons are connected to a common crankshaft. Actually, this is a crankshaft, here is cylinder, and this is the crankshaft. So yes, so the crankshaft to push towards and provide turning force to a force. Today's automobile engine typically have 4, 6 or 8 cylinders. So here is the cylinders, and this one is called piston, and it's keep up and down, and this is a sparking plug. Okay, so an automobile engine, several pistons are connected to common crankshaft, and nowadays we have a 6 to 8 cylinders, even 4. So a simplified drawing here, as I said, so illustrated what happened in this cylinder of an internal combustion engine. So it shows heat being generated at the top of the cylinder as a mixture of fuel and air is burned. So here is that mixture of fuel and air is burned, and it produce heat, and it keep push, and then again it's go up and down. So there is a mechanical work is done by using chemical work energy. So in an internal combustion engine, fuel is burned inside the mechanism that produce force. So we have bikes and car, 4-wheeler, 2-wheeler, 3. So all have, if it's engine, oil engine, then definitely nowadays we use this internal combustion engine. And that's good. Now move to the bottom of the cylinder. You see a connecting rods attached to the pistons is also connected to the crankshaft, and the turning of the crankshaft provide the force that drive the wheel. The engine as a group of system controlling the burning of the air and fuel is simple in theory but get a little complicated in reality. A number of systems are necessary to make an internal combustion engine run and allow it to handle the various functions of converting the chemical power of that fuel into usable torque or mechanical turning force and power. So I would highly recommend to watch an animations, so that will give you a clear understanding. So I have our channel, once I used to watch, nowadays it's become Lucius, I think the channel name. Actually, yeah, they create animations on different engineering topics, so you can try this one. Now the engine as a group of systems, so controlling the burning of the air and fuel is a simple in theory but get a little complicated in reality. A number of systems are necessary to make an internal combustion engine run and allow it to handle the various functions of converting the chemical power of the fuel into usable torque, mechanical turning force and power. So the electric system, every automobile has an electrical system. Now we are talking about the electric system. We have done with the engine. Okay, so how long this video will be? Okay, how much we have done already? Okay, so we reach into that electrical system, then we will talk about fuel systems, that how it connected with that, and that is what we need to know in the basics. So yes, right, so we talk about this chapter 1. We have lots of things to discuss about. Fine. We talk about how it work together, energy, force, work, power, and converting heat energy into motions, then engine of group system, the engine as a group system, then transferring torque. Okay, go there, engine as a group of system. Now let's talk about it. So the electrical system we are talking about, right? Controlling the burning of an air fuel is simply a theory but get it little complicated, right? So the electrical system, so every automobile has an electrical system consist of a series of complex part, chemical and metal within the battery store chemical energy and create electrical power on demand. So this power is used to operate a starter. starter, and or electric motors, starters, electric motors that turn or cranks or crankshaft and start the engine. So this electrical energy must also, so what is the crankshaft and the start the engine? So the electric energy must also power the electric fuel pump to deliver the fuel to the engine. So in addition, the computers and ignition systems deliver the high voltage spark used to ignite the air and fuel mixture inside the cylinder. So once the engine is running, a belt attached to the front of the rotating crankshaft turn an alternator or electric generator, so that produce electricity. So this electricity is used for several purposes: to operate the vehicle's electric systems necessary to turn the engine, to maintain or recharge the battery as a source of steering power, to operate the light and blow motors, radio and other necessary electronics. So modern automobile electric systems typically include one or more electronics control unit and computers. So that it is basically a very, nowadays car become a chalta firta computer hai. So the monitor and the operator mainly operates many other parts and systems. Automotive computers we will discuss later in the electrical system. Let's talk about the fuel system. To make an engine run, there must be a system that handles fuel. Our fuel systems include a tank to hold the fuel, an electric fuel pump that moves the fuel out of the tank, a filter to trap particles that could damage the inside of an engine, fuel lines to carry the fuel from the tank to the engine, and a fuel injection systems. So show the part of a fuel injection system. So older car made use of a mechanical device called carburetor. So we learn about carburetor to make the final delivery of the fuel to the engine. Carburetors were phased out during the 1980s and replaced by the motor reliable and efficient fuel injection system. So nowadays we inject the fuel and burn them. So fuel injection system provide a fine mist of fuel and air in precisely measures amount to be burned in the cylinder. On today's car, the operations of all fuel injection systems is monitored and controlled by computers or electronics control unit. Fuel systems are discussed later in the fuel system. Now here is that connections, let me tell you. So this is the various elements of the car's electric systems include a battery and a starting, charging and ignition systems, a computer and a lightning and auxiliary circuit. So first ignition start and then it's giving the fuel. Actually computer connected through batteries and then computer control all of them, like starting engine, this motor, right, starter and then ignition systems, then it start motors, then injecting fuels and then horn circuit and charging systems and all. It is all about electric system. So here is the fuel pump gauge here and fuel pump gauge. Okay, fine. So what is this? A typically fuel injection systems for a late model vehicle. Now fuel injectors and fuel rail is there, fuel pressure regulator, here it regulates fuel return line, fuel pump gauge standing unit and fuel cap. So yeah, we need to learn about more about control systems and all to understand how to control them. So the cooling system, the burning of the fuel air mixture produce that sometimes up to several thousands degree. Oh my god. The burning of the fuel air mixture produce heat sometime up to several thousand degrees and Fahrenheit. So the heat generated is so greater that without special control engine part could be wrap or melt. So to dissipate the excess heat, your car has a cooling system. An engine driven coolant pump provide continuous flow of liquid or coolant. so that circulate through a hollow space called water jackets. So water jacket is the in the non-moving parts of the engine. So in liquid cooled engine, the heat generated within the engine is transferred to the circulating coolant, which is a mixture of water plus antifreezer. So the coolant is circulated through the hollow tube within a radiator. So the radiator transfer heat to the air that flow around the tube. So air is moved through the radiator by an electric fan. So on some cars by a fan driven by a belt turned by the rotating crankshaft. So at highway speed, most of the cooling air is simply forced through the radiator by the movement of the vehicle. So some summarized heat generator within the engine is transferred to a circulating coolant and then to a outside air. So this transfer of heat keeping internal engine part below the temperature at which they would be damaged, and the coolant below is its boiling point. So here is the simplified form of parts of an automobile cooling systems and flow patterns of air coolant. So I definitely refer to watch animations where it will show you how actually cooling system work. So first we deliver water and coolant and all, then flow them, and then airflow is work, and yes, right, and then we try to keep this engine as cool as possible. So heat core and thermostat housing, then coolant flowing here, and radiator camp, and this air is going to flow here, and coolant and pump and coolant flow and radiator drain. So this is the system circulating hot coolant from the engine to the radiator, where heat is transferred to the outside air. Heat is transferring outside the air. Okay, here is the engine. It shows the lubricating oil is pumping through the internal combustion engine under pressures, and oil pumps circulate lubricants from the pan of the bottom of the engine through a filter to move part within an engine. And here is that oil pressure sensor and pressure relief valve, oil pump, oil color, oil filter, oil crankshaft timing gear, piston, oil cooling jet. And what I want to say is this is not enough here. We will go move on, and for now in this video we need to stop it, and in the further video we will talk about that. So thanks for watching and keep